Welcome everybody. We're going to learn in this video how to evaluate and simplify algebraic expressions. Two goals here. One is that you're going to use order of operations, which you should know, in order to evaluate numerical expressions that include powers. And the second thing you're going to be able to do after watching this video, maybe you can already, is you're going to evaluate and simplify algebraic expressions. And there is a difference between expressions that are numerical and expressions that are algebraic. No variables, variables. Pretty simple difference. Alright, so let's get right to it. And let's start with the order of operations. Now I know that you're familiar with order of operations. You've all been taught some clever way as far as how you remember what those order of operations are. Yet there are still some fundamental flaws in people's understanding sometimes. Now I'm going to try to help you understand this completely and perfectly. Okay, order of operations. First of all, here's an acronym that I like to use in order for you to remember which operations come in what order. Now, many of you might be used to the acronym PEMDAS, where you put a P there, and that would stand for parentheses. I prefer GIMDAS or GIMDAS, however you want to pronounce this, because instead of saying parentheses always come first, I prefer to use the term groupings or grouping symbols because there are many different things that can come before exponents or multiplying and that kind of thing. So first thing we're going to write down is grouping symbols or just groupings. And groupings come in many different forms of an equation. Yes, they can be parentheses, all right, and you would all recognize brackets as groupings. They can be other things, you know. Sometimes you have a radical that serves as a grouping symbol. Sometimes you've got a division bar that serves as a grouping symbol. Sometimes you have a logarithm. There's lots of different things that can be grouping symbols. Always take care of what's inside a grouping symbol before you do anything else. All right, then the rest of this you're super familiar with. Of course, the E stands for exponents. That's always the next thing you look at after groupings. Then multiplication, division, addition, and subtraction. So that's not news to you. I did mention that some people have some fundamental flaws in their understanding of the order of operations, and to try to clarify that, I've made kind of a list of priority levels, and we're going to group each of these operations into the appropriate priority level. And even though there are 6 operations here, six different types of operations, you're going to notice I've only got 4 priority levels as far as how you're going to treat order of operations. Now, the highest priority, or priority 1, whenever you're simplifying an expression, is you always go with the grouping symbols first. So we'll put that here. And then after you take care of everything that's in a grouping symbol, your second priority is always going to be exponents. So those two are exactly the way that you've learned them, but here's where the difference comes if you didn't learn this correctly the first time. Turns out multiplication and division have equal priorities. So we'll put both of those here on the third priority level. And the reason why that's important is because you don't always multiply before you divide. In expressions where there is multiplication and division, you do whichever one comes first. You go from left to right, and I will show you that in an example here in a moment. And in the same way, addition and subtraction have the same priority level as well. You don't always add before you subtract. You do whichever of those comes first, going from left to right within an expression. Well, let's see how that works out then. You see the expression that I want us to evaluate. And by the way, whenever you're told to evaluate something, that literally means find the value of it. And you always come out with a single number when you're told to evaluate. More on that direction or that command a little bit later on in this video. One other thing I'm going to do really quickly is I'm going to move this little priority level drawing that you've already got written down anyway, so that I can show you the work the way I want it to be done. And as far as how I want your work done, here's what I'm looking for. Every time you're working with an expression or an equation, the first thing I ought to see on your paper for the first line of the problem is that expression or equation written down. Now when it's an expression and you're simplifying or evaluating, what you can do is you can then put an equal sign off to the side, and then you can go ahead and go through the first step of the evaluation or simplification process. All right, a little more on that in a moment. Let's go ahead and take a look at what operations are involved within this expression. All right, you see we've got division, we've got multiplication, we've got a grouping symbol, and within a grouping symbol we've got subtraction and addition. Well, we know that we're going to go ahead and take care of the grouping symbol first, what's within it, and so we're going to go ahead and ignore the 16 and then the 4 and all that. Right now, let's just go ahead and copy that down. We'll still have 16 divided by 4, and then the multiplication there. And then select inside the grouping symbol. And inside the grouping symbol, we've got subtraction and addition. Now, here's where I was talking about a little bit ago. You don't always add before you subtract. You do whichever one comes first. And in this case, the subtraction comes first. So we'll do 3 minus 5, which is negative 2. And then we'll take care of the addition on the next step. Okay, now back to the way I want you to show work. I don't want you trying to be super paper conservers, all right? I don't want you writing an entire problem on a single line. It might serve you well for some things, but it's not going to serve you well ultimately as you progress through your math career. What you need to do is you need to have no more than 2 expressions written on the same line of a problem. Now here's one expression, there's 2 expressions. And they have to be equal to one another if you're going to write them on the same line. And then what you do is, for the next step, you put an equal sign underneath this one. All right, you always line up your equal signs, and then you continue the process. So we still have to work with what's inside of our grouping symbol, and that's addition. So we're not ready for the division yet. We're not ready for the multiplication yet, but we can go ahead and say negative 2 plus 10 is 8. All right, now I still put parentheses there, but there's nothing else to do in the parentheses. We got a single number, so we're done with grouping symbols. And since we're done with grouping symbols, that means the last things we need to take care of are the division and the multiplication. And those go from left to right because they have the same priority level. So we're not actually going to do 4 times 8 here, get 32, and do 16 divided by 32, which is 1/2. We need to take care of the division first. We need to do 16 divided by 4. And then take that quotient and we'll multiply it by 8. That's how you use order of operations correctly with multiplication, division, addition, subtraction, and so forth, according to that priority level that I'm trying to teach to you. All right, pretty simple, right? Good. Now let's go on to the next step here. I said we're going to be evaluating numerical expressions using order of operations, and that those expressions we're evaluating are to include powers. So let's look at including those powers. Now you know how to work with powers. You know what an exponent means, don't you? So in this set of examples, I'm going to show you how to use powers along with decimals, along with fractions, and along with negative numbers. All right, and especially we'll have to emphasize the difference between these last 2 expressions when we get there. All right, remember the way I want you to show your work. I want you to copy down the original expression and then put an equal sign off to the right and then write the equivalent version of that expression there. You know that raising something to the 3rd power means you multiply it by itself 3 times. Now, you don't have to show this step. I'm just trying to make sure we understand what we're doing the first time through an example. All right, so 0.4 times 0.4 times 0.4 is what that means. All right, so now what we're going to do, 2 things. Since we're working with decimals, we need to know how many decimal places are going to be in our product. And remember, that depends on the total number of decimal places within your factors. We've got 1 decimal place in each factor, which means our product is going to have 3 digits after the decimal. Okay, then we need to go ahead and multiply 4 times 4 times 4. That's 16 times 4 is 64. We know that that's going to give us a 64, and we know that we need 3 digits after the decimal place. So we're going to have to use a 0. 0.064 is what you get for 0.4 to the 3rd power. All right, now with fractions. What do you do whenever you raise a fraction to a power? Well, I could do the same basic thing I did over here where I write out 2/5 times 2/5 times 2/5 times 2/5. But I would rather emphasize another property to you. The property that you use whenever you raise a quotient or a fraction to a power. If we wrote out 2/5 times 2/5 times 2/5 times 2/5 and we multiply the numerators together, we would just be multiplying 2 times itself 4 times, wouldn't we? Or in other words, the numerator would just be 2 to the 4th power. And when we multiplied the denominators, we would be multiplying 5 times 5 times 5 times 5. So we would just really be figuring out what 5 to the 4th power is. So whenever you're raising a fraction to a power, you can just individually raise the numerator and the denominator to that power, as you see me doing right here. All right, now 2 times 2 times 2 times 2 is 16. 5 times 5 is 25, times 5 is 125, times 5 is 625. Now you hear me doing the math without a calculator. Many of you will be permitted to use calculators, but you need to be able to handle this without a calculator as well. All right, especially when it comes to this next two problems, calculators can be misleading if you don't know what you're doing. All right, now in these last two examples here for evaluating powers, I'm looking at when you have a negative sign in your base, or apparently as part of your base. Now I want to remind you of something very specific so that you know the difference between these two problems here. And that's that whenever you have a negative number, there's really multiplication involved right there. Negative 3 is really the same thing as negative 1 times 3. Now that's important here, and you'll see why, I think, as I work this out. This first problem then is really the same thing as negative 1 times 3 in parentheses being raised to the 5th power. Whereas the second problem, there's no parentheses here, is there? So it's just negative 1 times 3 to the 5th power. Now, it's very important that you notice the difference between when the negative sign was in the parentheses and when it was not in the parentheses. All right, now let's simplify the one where the negative sign was in the parentheses. If I follow my order of operations, I do the grouping symbol first, I get negative 1 times 3 is negative 3 to the 5th power. Now I know that's just rewriting what we already wrote, but really that means we're going to have negative 1 to the 5th power, which is negative 1, and then we're going to have 3 to the 5th power, which is 243. We're going to get a negative result there. Now I haven't shown you anything wrong, but it's not going to illustrate what I wanted to. I'm going to change the problem slightly here. I'm going to make that an even exponent. So let's make that negative 3 to the 4th power. Or heck, let's just keep it simple. Let's make it a 2nd power. Alright, so that'll be squared, and then negative 3 times negative 3 is positive 9, correct? Okay, so there we go. Now, let's take a look at when there were no parentheses around that negative sign. That becomes negative 1 times 3 to the 5th power. Now, there's no grouping symbol here, is there? But what we do have is multiplication, and we've got an exponent. And don't exponents always come before multiplication? All right, let me change that to a 2 as well, that exponent, by the way. Just so you can see the difference in these problems a little better. Now here what we're going to do is we're going to go ahead and square the 3. So we'll have negative 1 times 9. And then we still have to do the multiplication, so we're going to get negative 9. All right, so very important whenever you involve powers that you pay attention to where the negative sign is in parentheses or not in parentheses. It makes a big difference. And your calculator will mislead you with those examples in particular. All right, so that's using order of operations to simplify expressions. That's all of goal 1 for this video. Let's go on to goal 2, which is for algebraic expressions. Now, some quick terminology I want to go through here. First of all, vocabulary that you need to know whenever you're working with expressions. You need to know what terms in an expression are. And also, side note, algebraic expressions have to have variables in them, don't they? All right, well, you recognize what the terms are and how many there are in an algebraic expression by finding the subtraction and the addition signs, because each term is always separated by an addition or subtraction sign. All right, so you see there's 1, 2, 3 of those. So there's 1, 2, 3, 4 terms in this unsimplified version of this expression. Okay, now our product is always going to be a single term. 2 times n, that's 1 term. Quotients are always a single term as well. All right, 4 terms. And the terms with variables are called variable terms. So you've got 3 variable terms there. The term without a variable, remember, is called a constant term. And then within the variable terms, you have a coefficient, the numerical factor, and then you have the variable factor as well. All right, and then remember, you look for like terms. You'll see all that as we go through examples. Now, when you're given algebraic expressions, there's 2 commands that you'll ought to be given that people don't really fully understand the meaning of. Now, I'm going to give you kind of my definition, not technical definitions, but if you'll follow what I tell you here, then you'll always simplify expressions appropriately, assuming you don't make any math mistakes, of course, and you'll know what it means to evaluate expressions as well. Whenever you're told to simplify an algebraic expression, here's what I want you to do with it. Pause the video and write this down. To simplify means to follow order of operations until it is not possible to continue. Okay, when you simplify expressions, sometimes it's still going to look pretty complicated in the end if you don't have like terms that you can combine, for instance. But you just keep going through order of operations till nothing else is possible. Then when you're told to evaluate an expression, this is what it's telling you to do. You're supposed to substitute specified values for variables and then simplify. When you're evaluating an algebraic expression, they're always going to tell you what x is and what y is, and they're going to say, well, if x is this and y is this, what's the value of the expression? Remember I said earlier when you evaluate that you're supposed to get down to a single value? Well, since they tell you the values of the variables, you can do that with algebraic expressions as well. So first substitute and then simplify. All right, let me show you how to do each of those things. And I'm going to be trying to work in some fractions and other things along with you here too. You can kind of see that in the second part of this example, right? Okay, so let's simplify, which means we're going to follow order of operations till no more can be done. Remember, I always want you to copy down the original expression first, and then to show your work, you're going to go ahead and put an equal sign at the end of that, and you'll follow through with the first step, and then you'll keep doing the subsequent steps underneath. All right, don't ever write out an entire problem on one line. We're not trying to conserve paper. We're trying to do things correctly here. Okay, so I want to look at following order operations here, and you're going to notice we've got, well, a product there, 9 times p as a product. We've got subtraction, we've got more multiplication, and we've got more multiplication even. Then we've got a grouping symbol, and we've got addition within that grouping symbol. Well, out of all that, we need to look at the grouping symbol first. However, in this case, it's not possible to combine the terms in the grouping symbol because you cannot add unlike terms, as these are. So we're going to have to forego that step, all right? The next thing that we're going to look at then is the multiplication involved. Now, there was 9 times p, but we can't do that yet. We don't know what p is. There's negative 10 times p, but we don't know what p is again. But what we can do is go ahead and use the distributive property. That's the only property from section 1.1 that I didn't include in the video because I think you know it super well. Let's go ahead and distribute then this 10p. And we'll include the negative sign in front of it. We're going to copy down the 9p. Always treat a term as having the sign directly in front of it. If it's addition, that's a positive term. If it's subtraction, that's a negative term. Negative 10p times p is going to be negative 10p squared, and I need to include that negative as a subtraction sign. And then negative 10p times positive 2 is going to give me negative 20, so I'll put minus 20. And then there's really nothing, negative 20p, correct? And then you notice that I've got a pair of like terms here, so I'm going to go and combine those. 9p minus 20p is negative 11p. And then if terms, even though they have the same variables, don't have the same exponents, they're not like terms, so there's no more simplifying that can be done. Although often, hopefully you've been taught to write exponents in descending order. So I could put the negative 10p squared term first and then negative 11p second. That's using the commutative property, thinking about this as being addition, by the way. All right, never mind that. So then with the second expression, let's go and put our equal sign out here again. You're going to notice 2 pairs of like terms. You're going to have the r squareds are like terms, correct? I'm going to highlight those one color. And then the 2 terms that just have r to the first power in them are also like terms. I'll highlight those as well. Now, the only operations that we'll be able to do here are the additions and subtractions. But remember, when you're doing addition and subtraction with fractions, you need the terms that you're combining to have the same denominator. So I need to have the same denominator for 3/5 r squared and negative 2r squared. And of course that denominator would be 5. I can rewrite 3/5 r squared, well, leave it as 3/5 r squared. and I can rearrange the terms in an addition and subtraction problem. So I'm going to bring the minus 2r squared to the front, but instead of writing minus 2, I'm going to write minus 10 over 5. You ought to know how to get common denominators. If you don't, that's something you can ask about in class. But this is 3/5 r squared minus 10/5 r squared. And then for the 1/4 r and the 5/2 r, well, 4 would be the common denominator there. So we can leave the 1/4 r as 1/4 r. Make sure you put the plus sign there. And then we can change 5/2 r into 10/4 r. All right, then combine your like terms. 3/5 minus 10 r squared minus 10/5 r squared is going to be negative 7/5 r squared. And then 1/4 r plus 10/4 r is positive 11/4 r. So simplify expressions, follow order of operations till there's nothing else you can do. Then let's talk about evaluating expressions. Now this video is getting a little bit longer than most of them are going to be, but not too much more to do. 2 more examples and we'll be done. So hold on there. I'm telling you to evaluate the expression for the given values of the variables. Every time you're told to evaluate, you're also going to be told what the values of the variables in that expression are. Here I've told you that x is negative 2 and y is negative 3. So, since I don't have room to the right of this, I'm going to go ahead and put my first equal sign below that expression. And I'm going to substitute these two values into the expression. Now, if you'll follow this guideline, you will not make nearly as many mistakes as people that refuse to do this. Whenever you're substituting into an expression, what I would always do is wherever there's a variable that you're going to substitute for, put parentheses there. And you can kind of see me doing that right here. And what that's going to help you do ultimately is not make mistakes with your signs. And then when you put the parentheses there, substitute the given value in those parentheses. So I'll put a negative 2 in for that x. I'll put a negative 3 in for this y and for this y. All right, now let's scope out what we need to do here. There's nothing to actually do inside of any of these parentheses, is there? So we can go past the grouping symbols and go on to exponents, and we've got 2 exponents here. We're going to have to do negative 2 to the second power. Now, you don't multiply until after you've taken care of exponents, so we'll raise negative 2 to the second power, get 4, and then we'll multiply that by 3 on the next step. All right, nothing to do with this negative 3. We could write it as minus 3 instead of plus negative 3. Either way is fine. And right here, don't multiply these two negative signs yet because you have to do exponents before you do multiplication, right? So just copy down that subtraction sign. Negative 3 to the 4th power is going to give you positive 81. All right, so then we've still got one multiplication to be done here. Negative 3 times 4, that's negative 12. Then I'll put minus 3 and a minus 81. And then we can just go ahead and go from left to right. Negative 12 minus 3 is negative 15. Negative 15 minus 81, negative 96. All right. If that didn't make sense, try, or even if it did, pick a couple from your textbook and try them out and make sure you can do this correctly. One more example to show you with evaluating expressions. Here we go. Evaluate this expression for when p is equal to negative 1 and when q is equal to 4. Well, do what I told you a little bit ago. Let's go ahead and put parentheses everywhere there were variables first. All right, so where this p is, I'm going to go ahead and put parentheses there. And then minus 2, and then where the q is, I'll put parentheses. So I'm ending up with some parentheses inside of parentheses, that's fine. And then let's go ahead and put in the required values. For the p there was a negative 1, the p here was a negative 1, and then the q was a 4. Alright, now in the numerator, we've got to go ahead and take care of what's in the grouping symbol first, don't we? So, inside the grouping symbol, we've got subtraction. We've got multiplication. Let's do the multiplication. 2 times 4, of course, is 8, so I'll have negative 1 minus 8. Now, I mentioned to you earlier that division bars or fraction bars can be grouping symbols. We've got to finish everything on top and then everything on bottom and then do the division at the very end. All right. Anyway, so let's go ahead and take care of what's in the bottom part as well. That's separate from the top. We can go ahead and multiply 3 times -1. That's -3. And then let's go ahead and square -3. -3 times -3, of course, is positive 9. All right. Now in the numerator, we can go ahead and do this mentally and do a couple steps at once. -1 minus 8 is -9, right? And then we'll have to do -9 to the second power. That's 81. So leave the -4 alone. We'll multiply that by 81 in the next step. Then -4 times 81 is -324. And then -324 divided by 9. It's going to give you -36. All right. So you ought to know your order of operations. You ought to know how to simplify expressions that involve exponents. You ought to know how to evaluate and how to simplify algebraic expressions. Thanks for your attention. I know it's taken a little bit of your time here, but it was well worth your time. I will talk to you later. See you guys.